Welcome to this lesson on reduction half-reactions. In electrochemistry, understanding how electrons move between chemical species is fundamental. Today, we'll explore the concept of reduction, which is one of the two key processes in redox reactions. By the end of this lesson, you'll be able to identify and write reduction half-reactions with confidence. Let's start with the basic definition. Reduction is the gain of electrons by a chemical species during a reaction. The key word here is gain. When a species undergoes reduction, it accepts electrons from another species. This is one half of a redox reaction, where one species gains electrons while another loses them. The term reduction might seem counterintuitive, but it refers to the reduction in oxidation state that occurs when electrons are gained. There are two important concepts to understand about reduction. First, the oxidation state of the species decreases during reduction. Remember, gaining negative charges makes the overall charge more negative, which means the oxidation state goes down. Second, electrons are physically gained by the species. These electrons come from another species that is being oxidized. These two concepts are interconnected and help us identify when reduction is occurring. Now let's look at the general format for writing a reduction half-reaction. The standard form is x to the power of n plus n electrons yields x here. X represents any chemical species, n plus is its initial positive charge, and n electrons are gained. Notice that electrons always appear on the left side of the equation as reactants. After gaining electrons, the species ends up with a lower charge or becomes neutral. This format applies to all reduction half-reactions, making it easy to identify them. Let's examine a specific example with copper. The half-reaction is copper 2 plus ion plus 2 electrons yields copper metal. Here, a copper ion with a charge of plus 2 gains 2 electrons. The oxidation state changes from plus 2 to 0, meaning the copper ion is reduced to neutral copper metal. This is a common reduction reaction you'll encounter, especially in electroplating and battery chemistry. Notice how the electrons are on the left side, confirming this is a reduction process. Here's another important example with chlorine. The half-reaction is chlorine gas plus 2 electrons yields 2 chloride ions. In this case, chlorine gas, which is a neutral molecule, gains 2 electrons. The oxidation state of each chlorine atom changes from 0 to -1. This produces 2 chloride ions, each with a -1 charge. This reduction is crucial in many chemical processes, including the production of hydrochloric acid and water treatment. How can you quickly identify a reduction half-reaction? There are 3 key indicators. First, electrons always appear on the left side of the equation as reactants. Second, the oxidation state of the species decreases from reactants to products. And third, the species gains negative charge or becomes less positive. If you see these 3 characteristics in a half-reaction, you can confidently identify it as reduction. These recognition tools are essential for balancing redox equations and understanding electrochemical cells. Let's summarize the essential concept. Reduction half-reactions show electron gain and always result in a decrease in oxidation state. Remember, reduction means gaining electrons, which appears as electrons on the reactant side of the equation. The oxidation state always decreases during reduction. Understanding this fundamental concept will help you analyze complex redox reactions and electrochemical processes. Practice identifying and writing reduction half-reactions to master this important skill in electrochemistry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.